Welcome to the Level 4 video on ordinary differential equations. Today we're going to be looking at second order linear ODEs. So, how do we solve second order differential equations? Of the form a times the second derivative of y with respect to x plus b times the first derivative of y with respect to x plus c times y is equal to some function of x. How do we solve these things? Where of course a, b and c are all constants here. And to solve this, the first thing we do is we solve the homogeneous part first. If you don't know what that is, we'll come to that in just a moment. So the homogeneous part is the following. So it's the same left-hand side as the general form above. The function of x is just 0. And this will give us what we call the complementary function. Okay, and once we've done that, we then solve the inhomogeneous part. And this gives us what we call the particular solution. And of course we're looking for the general solution here. So the general solution is the complementary function plus the particular solution. And this is really important. So we do it in these two different stages. Okay. And when we're solving the homogeneous part, we're going to have three different cases when we solve the auxiliary equation. So case 1, 2 distinct roots, and then our solution is y equals some constant times the exponential of r1t plus another constant times the exponential of r2t. Okay, where the roots here are r1 and r2. And we have case 2 of 3. In this case we have two complex roots. So the solution would be y equals some constant times the exponential of lambda t times cos of mu t plus some other constant times the exponential of lambda t times sine of mu t. Okay, where our roots here are is lambda plus or minus mu I. So when you solve the auxiliary equation, you get a lambda, you get a plus or minus u, and those lambdas and mu's are the mu's and lambdas you see in the y above. And then we have the third and final case, when we have repeated roots from the auxiliary equation, and then y is c1 times the exponential of rx plus c2 times x, which is the important x, times the exponential of rx. So r is just our repeated root. And those are the three cases that we have. Okay, so let's look at an example. Okay, so the example is find the general solution of the following differential equation. And the differential equation is y double dash plus y equals x, okay, where dash here is d by dx. And let's write down the solution to this. Okay, so first of all, we know what we're doing. We want to solve the homogeneous problem. Homogeneous problem, or the homogeneous part. Okay, so the auxiliary equation is m squared plus 1 equals 0. That's because we have a coefficient of 1 in front of y double dash and a coefficient of 1 in front of y, and we have we have a coefficient of 0 in front of y dash, which is why we don't have an m in our auxiliary equation. So this implies that m is plus or minus I, which implies that our solution, when we refer back to our cases, we're in case 2, two complex roots. Okay, so we know that lambda is 0, so our solution is c1 times cos of x plus c2 times sine of x. Okay, and it's 1x because mu was 1. So that's the homogeneous part solved. Now to solve the inhomogeneous part, so we make a guess, and because we have in the inhomogeneous part we have a polynomial of x, we make a guess of a polynomial up to and including that degree, a general polynomial. So I'm guessing ax plus b is a solution so let's go ahead and substitute it in. So y double dash plus y would be ax plus b. This equals x, so it implies that a is 1 and b is 0. So the general solution here is the complementary function plus the particular solution, which is c1 cos of x plus c2 sine of x plus x. So we have our solution, but of course we can check this, which I fully recommend. So let's calculate y double dashed and y. So y was c1 times cos x plus c2 times sine of x plus x plus x. So y dashed is minus c1 sine of x plus c2 cos of x plus 1, and y double dash is minus c1 cos of x minus c2 sine of x. So y double dash plus y double dash plus y equals minus c1 cos of x minus c2 sine of x plus c1 cos of x plus c2 sine of x plus x, and that all equals x. And the cancellation we have cos cancels with cos and sine with the sine. So x equals x, which is true, and our solution is valid. Thanks very much for listening.